some more fun today. Okay. The second fundamental theorem of calculus is very easy concept. Okay. What happens when we take the cube root of x cubed? We get x. What happens when I take the, let's see, I'll do an easy one. The inverse tangent of the tangent of pi over 4. Yep, pi over 4. Okay. That happens because they're like inverse operations, right? Okay. The derivative of an integral is the function inside. Okay. Why does this make sense? Okay, we're taking the derivative of an antiderivative, so we're just back to square one, right? Okay. What I want you to notice about this is that our integral is from a to x, okay? When we do, if we were to do this antiderivative, right, we would have the antiderivative of x minus the antiderivative of a, all right? And then we take the derivative of this to get back to f. So the x always has to be in the integral, okay? And it has to be a limit of your integral. Your integrand, what's inside, is going to be of a different variable, okay? Does that make sense? Why it needs to be, these need to be t, this needs to be an x, okay? A is just any constant. Most of the times you'll see 0, but it could be 7, 5, 251. It doesn't matter. It just needs to be a constant, okay? And of course, the derivative of a constant, it goes away. It doesn't matter what it is. Okay? So, let's see what this looks like. I have the derivative with respect to x of the integral from 3 to x of t cubed plus 1 dt. Okay, now it says derivative with respect to x, so your answer should have x in it, right? Okay, so the derivative of the antiderivative is just a function. So this is just x cubed plus 1. Yeah, well, let's look at this, okay? Let's do the hard work here. If we were to take the antiderivative of this, we would have 1/4 t to the 4th plus t evaluated from 3 to x, right? So we would have 1/4 x cubed plus x minus 1/4 3 to the 4th. What? We would have this, right? Well, then when we take the derivative of it, what happens to these? These go away. So the constant doesn't matter. How about here? The derivative with respect to x of the integral from 1 to x of e to the t squared dt. What's the derivative of the integral? E to the x squared. Okay. You know what? We're gonna do this. Before we do that one, we're gonna do this one. What's different about this one? The x and a are flipped, right? So this is the same thing as the derivative with respect to x of the integral, the negative integral from 7 to x, correct? Okay, so the derivative of our antiderivative is negative cosine of x. Alrighty. Alright, how about this one? Okay, so when we take the derivative, we're going to plug x cubed into our function. So we get the sine of x to the 6th. However, this x cubed is a function inside all of it, so we're going to have to perform the chain rule. So we're going to have to multiply by the derivative of x cubed. Who's running above me now? Is this Miss Myers? Marsh is not above me. Yeah, who's up here? Is it Myers? She doesn't usually have loud ones. It is nice not having Mr. Marsh upstairs though. Yeah. Above me. He was, they drop things and roll things.
Oh yeah, first semester.
Where Mr. Pena?
Pretty loud. Just like one day we all like started jumping.
All right. How about this one? Okay. I want the derivative of this.
The bottom one was negative 3x.
Yeah, all it is, the derivative of the antiderivative is just a function, but we got to plug x cubed in, and then 3x squared.
Wait, so why would the last one be sine x to the 6 times 6?
Because it was sine.
But x to the 6, why would it not be 6x to the 5th times sine x to the 6?
Because the function that was inside was x cubed. It's whatever is in your integral.
Okay.
It's the limit of integration. Okay? All right.
There's like polynomials and things though too. Like instead of x cubed, like x cubed plus 4x squared.
Yeah, it's possible to have any function in your as a limit of integration. So you'll just have to remember the chain rule. Now, come AP test time, that's going to be like one of the first things that you forget to do. Please don't forget to do that. Okay? You're going to be really great at this right now. And then, like, in a week later when I give you this problem, you're going to forget to do the chain rule. Okay? Prove me wrong. Okay. These kinds of problems are very, very common on the AP test and my tests. Okay? So let's look at it. G of x is the integral from 0 to x of f of t dt. Okay? So if our function is g, and we have the graph of f, what's the relationship?
G is the derivative.
Which one's the derivative?
G, F.
F is the derivative of g,
Okay.
right? Because when we take the derivative of g, we're left with f of x. Okay. So first of all, how do we calculate g of 1? Nope.
We have to do the
Okay, so g of 1 means the integral from 0 to 1 of f of t, right?
yeah.
Here is f.
Oh. So when
You just use geometry.
So we need to use geometry to find the area under the curve between 0 and 1.
Or it's just this one.
Okay. How about g prime of 1?
That's what you put in. Right? So G prime is up, right?
Okay. G prime is f of x. So here is f of x. So here's 1. Our coordinate is 1, 0. So it's 0. Okay. The second derivative evaluated at 1. This is the graph of the derivative.
Which one?
Okay, this is g prime, right? Okay. I want the second derivative. So I want the derivative of this graph right here. So what do we need to look at? The slope. What is the slope here at 1? Okay. Are we putting it together?
Yeah, that's confusing.
Not confusing. Okay. We've done it before, right? We've done this before.
Yeah.
Okay.
Who's confusing to each
Okay. Just take your time and think about what is going on. Okay. If g is the integral of f, okay, and you have f, then write down, okay, that this is your derivative graph. Okay, we did a lot of work with working with the derivative graph, right? Nothing's really changed except now we know how to find g, right? We know how to go backwards from it, okay? These two things, this is what we worked with last semester, okay? So write whatever notes you need to help you, okay? So now remember, this is the derivative graph of g, okay? Where are we increasing? If we have the derivative graph, we're increasing where our derivative graph is positive. And where is that happening? Negative 1 to 1. Decreasing, we look at where our derivative is negative. So, negative 2 to negative 1 and 1 to 2. Concavity. Okay, so if I want concave up, I look at where my derivative is. So we're looking at where it's increasing, okay? So from negative 2 to 0, right? Concave down, we're looking at where our derivative is decreasing. So from 0 to 2. What? So this is a good review of the stuff we did last semester, right? We've just tacked on one extra concept. We will do a lot more work with these types of functions. If we're going to do something Monday with it in class, we're going to do something, you guys are 6-hour Wednesday in class. Okay. Okay, let's talk about the first part of our fundamental theorem of calculus. Okay, the second part of it was what we did first. Now we're going to jump back to the f of b minus f of a, right? Okay, we are going to work with problems that look like this. We are given the derivative. We are given a value, a function value, and we want to find another function. Okay, so there are two different ways we can do this. All right, so first of all, if I have the derivative, how do I want to get back to the function? Okay, so we want to take the integral of our derivative, right? We want to take the antiderivative of our derivative to get back to our original function. Now, the fundamental theorem of calculus says that the integral from 0 to 3, where did I get 0 and 3 from? 0 and 3, okay, should equal the antiderivative at 3 minus the antiderivative at 0. Okay, now why did I write little f's this time? Well, this is our derivative, right? So if this inside is the derivative, then our antiderivative is going to be the function, right? Okay, so what we can do is we can take our integral from 0 to 3 of 4x, so 2x squared evaluated from 0 to 3, and that should equal f of 3 minus f of 0.
Is there apostrophe on the at in the question? I can't tell. Like to indicate that it's a derivative.
Yeah.
Okay.
So when I evaluate this, we get 18. So f of 3 is what? Okay. Now, this is the way the fundamental theorem of calculus lays out these problems. Okay. Let me show you a second way we can do these problems. Okay. I'm not getting a real good vibe from you guys. Not having it. Okay, so our derivative was 4x, correct? And we want the actual function evaluated somewhere. So let's just get back to our original function, okay? To get our original function, we need to take the antiderivative, correct? Well, what is the antiderivative of 4x?
2x
Plus c, because this is an indefinite integral, right? Can we find what c is?
Yes.
We know that f of 0 is 6.
And we have a 20.
So if f of x is 2x squared plus c, then f of 0, which is 6, should equal 2 times 0 squared plus c. C is 6, right? So our function should be 2x squared plus 6. Now, can we find f of 3? Do you think this way is easier? I figured you would, that's why I wanted to show it to you. Do I care which way? No. Is this way more work? A little bit. But if it makes more sense to you, then use it. Okay.
Can you just go back out and see if
What do you want to see? Okay. Basically, you have the derivative and a point on the function. You want to find another point on the function. Okay? Let's try another one. I take it you like the finding C way better? Okay. So here is our derivative. We have the function value at 2. So to find f of x, we can take the antiderivative of our derivative. Okay? Which is antiderivative of 6x minus antiderivative of 8x cubed. And then our plus c. Alright, so now we know that f of 2 is 3. So our function value is 3 when we plug in 2. What does that make c? Okay. So now we know that f of x is 3x squared minus 2x to the 4th plus 23. So now we can plug in -1 to get
Oh, crap.
you just need to smile when you say the answer. No. You don't know how one smile could change someone's day.
Oh, no.
Even that one, Aaron. As creepy as it is. Okay, you have a worksheet and some problems. Please do the book work and the worksheet. Yes.
Oh, how does one go from 81 to 96?
Don't worry about it.
And then do we have to do 92?
The problems are even changed.
Oh, thank God. Well, it's a good thing that we're still recording.
69.
Someone's gotta stop the recording right when they see it, and then they're not gonna be right.
And that someone is homie.
Don't be that guy, Aaron.
It's okay, he's alright.
Oh, that's right.
You go, Alpha homie. We know Aaron.
I was like, God, let's do all this.
Oh, no, Josh is on.
Yeah, Josh.